Okay, chapter 8 was all about you solving linear equations, two linear equations with two unknowns, and finding their intersection point using graphs and graphing technology. Today and the next 3 days are going to be about how do I solve those same linear equations without using graphing technology. So there's two methods that we're going to use to do it. The first method is the substitution method, which I've already shown you, and the second method is the elimination method, which I've also given you an indication as to what to look at. So the first method we're going to focus on is the substitution method. So what I want to do first is I like to label my two equations. Okay? What it does is it allows us to then, if we label those two equations, when we manipulate them, we know which equation we're working with. So in the substitution method, we want to isolate one of the variables and substitute that value in to the next equation. So what am I looking for? I'm looking for one of the variables to have a coefficient of probably 1, because then it's only one step and I'm done. Okay, now it can be done if the coefficient isn't 1, but that's the one that helps and makes it the easiest. Okay? So let's look at those two equations. Which one of those variables should I isolate right away? Y in which equation? In the A equation, that's right. So how do I isolate y in that equation? Y equals? Negative 5x out of 11. Excellent work. Okay. So now, I know what y is equal to in that first equation. So what I'm going to do now is I'm going to substitute it into the second equation. Fair enough? So equation B now becomes 2x plus 3, and instead of y, I'm going to use minus 5x add 11, which is equal to 7. Fair enough? So the one thing that I think is essential for you to understand is when you do any substitution at any time, you should put it in brackets. Excuse me. You should put it in brackets at all times, because we tend to forget when we have to transfer negatives through, when we have to multiply numbers through, we tend to forget that stuff. All right, so now from here I'm going to simplify and solve for x. Okay, so to simplify and solve for x, I got to get rid of the brackets first. So that's minus 15x plus 33 equals 7. So far, so good. Collect the like terms. Minus 13x.
Daniel Kreitner to room 1, please. Daniel Kreitner to room 1.
Add 33 is equal to 7. So far, so good. Okay, I need to isolate the x. So what do I want to do next? Subtract 33. So that's minus 13x equals minus 26. Divide by negative 13. X is equal to 2. All right, now remember this. Remember this. Last section, I found a coordinate, an x, y value that solves those linear equations. So what do I need to find now to finish this off? I need to find the y value, right? I need to find the coordinate. So when x is 2, what is y? So I can do that by using either one of these two equations and putting 2 in for x. Okay, it doesn't matter which equation I use. So I'll use A. 5 times 2 plus y is equal to 11. 5 times 2 is 10. So 10 plus y is equal to 11. How do I get y by itself? Subtract 10. What does y equal? 1. And finally, what is my coordinate where those two lines cross? 2 and 1. Bless you. Now last section, I said to you, you had a multiple choice question. It said 1 and 1 was a coordinate where they intersect. So how did you check all of the equations to see if they intersected? What did you do? Put them in for x and y, and made sure then that the left side equals the right, correct? Well, I have that coordinate again. Now, since I used A to solve most of this, I'm going to check it with B to make sure I have it right. So 2 times 2 plus 3 times 1 equals 7. What's 2 times 2? What's 3 times 1? 3 plus 4 is? Got it right. It's foolproof. Should never get any of these questions wrong, because you can check the answer every time to make sure it's right. Okay? So this is what we call the substitution method. We isolate one of the two variables and substitute it into the other equation to solve it. All right? I'm going to check one more of these equations. I'm going to do one more, and then I'm going to come back. Again, the example they use is one in which you need to write the equation up. That is going to be the issue for you. You writing the equation up. Now, just judging by the tests, the majority of you have that pretty well under control, actually. Okay, the two questions that you need to write the equations for were done quite well. All right, so let's have a look here. 192. Ryan bought 3 tickets and 6 hot dogs at an Edmonton Rush lacrosse game. The total cost of his purchases was $153. His friend Carrie bought 1 ticket and 3 hot dogs and spent $54. What was the price of a single ticket? What was the price of a hot dog? All right. So the first thing I do, what is x going to equal? No. What is x equal? What are our two variables equal? What are they? X is going to be what? Tickets. X is tickets. And y is hot dogs. Great. Okay? So how do I find out how much money I make? What do I got to do? Just in words, tell me what I have to do. No, in words. How many tickets I bought? And how much it equals. Okay? So how do I show that in an equation then? X plus y equals 153? 3x plus 6y is equal to 153. What do the 3 and the 6 represent? What is it? No? What are the 3 and the 6?
The amount of tickets.
You know? The amount. The amount for 1 ticket and the amount for 1 hot dog, is that right? Or how many I have?
How many?
How many I have, right. So the amount is actually the x and the y, correct? The price. Okay, so the second equation then is what? 1x. So what was the, how many? 3y equals 54. Okay. So what was the first thing I said that you want to look for in order to do this method? Coefficient of 1. Is there one up there, Liam? Which one has a coefficient of 1? Where are the coefficients found? Don't know. Where's the coefficients found? In front of the variables. Liam, these numbers here are called coefficients. They're found in front of the variables, right? So which one? The x does. Excellent work. Okay? So the x, right here. Let's isolate it itself, okay? So let's do that. How do I isolate x? X is equal to? What is it? Negative 3y add 4, or 54?
Yeah.
We agree with that?
Yeah.
Okay, I'm going to subtract the 3y to the other side. Right? Okay, I agree with you. Minus 3y plus 54. Okay? So what do I do now that I've isolated that x? What do I do with that equation? Substitute it into the other one. That's why we call it the substitution method, right? So a is 3 times, instead of x, minus 3y add 54, plus 6y equals 153, right? Okay, figure out the math on that, please. Oh. Uh-oh. Sure. Right. Lexi, downstairs. Okay, so what's the first thing I did now? What do I do now? Get rid of the brackets, distribute. Excellent. Minus 9y, add, what's 54 times 3? 162 plus 6y equals 153. Good so far? Okay. What's next? Could I do one more thing first? What's that? Collect like terms. I like that. Okay, minus 9y plus 6y is 3y, right? Okay, and then what am I going to do with that 162? This is a negative 3y. Very good. Good pick up. What do I do with that 162? Subtract it to the other side, so that's going to give me minus 9. Agreed? Okay, does everybody see what I did there? I added this to this, that gave me minus 3y, and I subtracted 162. Everybody see that? Okay, I did 2 steps at once. Alright, so that's it. And what's the last thing? Y is equal to 3. So what does that represent? $3 for hot dogs. So let's find out how much a ticket costs. Alright, so let's go 3x plus 6 times 3 equals 153. What's 6 times 3? 18. I need to subtract that 18 to the other side. 3x is equal to, what's 153 subtract 18? 135. Excellent. Divide by 3, and what does x equal? Good job. Good math. 45. How much were the tickets? $45. How much was the hot dogs? $3. So 45 and 3 would be my solution. Correct? Now I could put it back into this equation here, right? So that's 45. 3 times 3 is 9 plus 45 is 54. We got it right. I'm not showing you the work. You don't need to show me the work. You can do it in your head and you know that you're right. Perfect. But check it. Whether you do it on paper or you do it in your head, check it. That way you know you're going to get 100% on this test. Okay, so far? Sure.
Why do you have to isolate x on the first one?
I need to isolate one of the variables so that I can substitute them into the other equation.
And that, okay, so that's why.
So if you look at the last question, I isolated my y up here. Over here, I isolated x. Okay?
So it
Now,
doesn't really matter.
no, it doesn't matter. No. And then why did I choose?
Because it has one.
1 is the coefficient, so it's easy math then, right? Okay, I'm all about easy math. All right? Any other questions about that? Okay, so you're gonna get that. We got some people missing tomorrow, so I'm going to do that 9.2. I'm gonna do the elimination method now as well. Okay, so this one I think we're okay with. The elimination one might take a little bit of time today to do it. Okay, so we're going to use the same examples just to show you how. So the first equation in the first one was 5x plus y equals 11.
And 2x plus 3y equals 7.
Okay. Hang on to your socks. Okay. Here's what we look for again. We are looking to match up coefficients so that I get rid of, I eliminate, that's what we call eliminate, one of the variables. In order to do that, I'm going to somehow make sure that on the top one, I have a coefficient that has its additive opposite on the bottom one. Additive opposite means +4, -4. +5, -5. In order to do that, I'm going to use multiplication to make it happen. Okay? And again, easiest way to do this is to look for the one that has a coefficient of 1. Okay? So far you follow me? Additive inverse to 7 is?
-7.
You're confused about that?
No,
That was not the look I saw.
I forgot what it was.
Alright, so here's what's going to happen. I look at this y right here. I have a 3y here. I want that to become the additive inverse. What's the additive inverse of 3? So I'm going to multiply this whole thing up here by -3. Does everybody follow? So I got to multiply the whole thing by -3 times by -3. So A is going to look like this. Minus 15x minus 3y equals minus 33. Any questions? Any questions? Jacob?
I don't understand why you put.
Okay, that's the next step. Alright? So why did I do that? Because you're going to see why after this very next step. Alright? Just, everybody understands how I did it though, right? I just times all the numbers by the same value, correct?
Yeah.
Now the how and the reason why is this, Jacob. I rewrite this equation, 2x plus 3y is equal to 7. So far so good? So all I did was changed A, left B as is. Why? Why did I do that? Well, I'm going to add these guys together. I'm going to add them together. Minus 15x and 2x is what? Minus 13x. Minus 3y, add 3y is? O. That's not a number. It's a variable. And you change the y to an O? What is the answer? It's 0. It's 0. That's why I did it, Jacob. Now I've gotten rid of one of the two variables. So here's what I'm left with. Minus 13x equals minus 26. X equals what, Cooper?
2.
2. X equals 2. That's why I did that. Okay?
Yeah.
Seems slick, but I'll show you the next one, and it's not as, it's actually gonna be just as slick, but the reason is, okay, so now, but hold on, here's the thing, I'm not done, what do I have to find next? I have to find y next, right? Here's the beauty of it. Right now, I do exactly what I did on the substitution method to find y. Put it back in, solve for it. I do exactly the same thing. So the only difference between the substitution method and this one, in the elimination method, is the first 2 steps. After that, it's exactly the same. So now let's put it in. I'm going to put it in this one. 2 times 2 plus 3y equals 7. 2 times 2 is? I'm going to subtract it to that side, so 3y is equal to? 7 subtract 4? 3? I know that was a hard one. Okay? Y is equal to? 1. So my answer was 2 and 1. Exactly the same finish to that question. Then you can take this value, substitute it in here. 5 times 2 is? 10 plus 1 is? 11. Works. Works. Okay? Everybody's okay so far?
Yeah.
I just have one question. This is only gonna work when your y is none.
This works all the time.
Okay. It
This
doesn't
works
matter.
all, no, it doesn't matter. Okay, so I'm going to show you example 2. What do you want?
So I was wondering, for we don't use 3y, can we use 2x sometimes, like a equation by 2x, like make?
No, just wait. Just wait. Okay? No, you can't. Because if you times that whole equation by -2, you're going to get -10. And it's not gonna cancel out. It has to cancel out. Okay, now Lexi, just, nobody else, everybody else go like this, your mouse. Lexi, if I times this by 2 and this by -5, that would give me 10 and -10. That's where I'm going. Okay, now you have like you're using this as sound. Okay, so let's look at the second one that we did today. Let's look at the second one we did today. It is, yeah, thank you. You help me here. 3x plus 6y is equal to 153, right?
Yeah.
And then it was
X plus
3y equals 54.
equals 54. Okay? Okay. So this was the second question we did. Let's use the same method now. So again, I'm going to locate the coefficient that has a 1. That's what I would do. Okay? That's what I would do to get the additive inverse. So which one would I multiply? What would I multiply this by so that I'm going to end up canceling out on that top part? What do you think? What do you say? -3. I agree. If I multiply this by -3 and add it to that, what's that going to give me? It's going to give me the 0. So that's what I would do. Totally what I would do. I'm not going to do that right now. I'm going to show you something else. Because this method works great when you have the 1 coefficient, but it's not so easy when you don't have a 1 in there. So I'm going to show you how to do it if you don't have a 1. This one obviously has a 1. Actually, this one's a terrible one to use because it makes it so easy. Okay, if I didn't want to use -3 here, if I didn't want to use -3, what else could I multiply this bottom guy to cancel out? If I didn't want to cancel out the x's and I wanted to cancel out the y's, what would I? -2. Good for you, Wayne. What would I have to multiply by? -2. -2 would give me -6 here, and -6 and 6 make 0. All right, so I've confused everybody? Perfect. So let's try this again. 3x plus 6y equals 153. I'm going to keep that as is, right? All right. What do you want to multiply that bottom guy so that I can cancel out, I can eliminate one of those variables? For me? All right. I want the additive inverse. -2, you want to use -2? Okay, we can use -2. I wouldn't have, but that's okay. 2 times -2. All right, so I got to multiply that by -2. What do I get? X. Agreed? That by -2 is? Negative what? 6y. Don't let those things disappear. Okay? And then -2 times that is? -108. Awesome. Okay. Now, did I get rid of one of the variables? Well, let's find out. 3x subtract 2x is what? 1x. Right. 6y subtract 6y is? 0. Yeah, it's 0. 153 subtract 108 is? Done. I got my x value already.
So come you wouldn't have used -2 to
I would have used -3, so these two cancel.
okay.
Okay? It's fine now. That's the beauty of this. You can use whichever numbers you want. Alright? I would have used -3. Because I know that when I multiply this by -3 and add it to that, that's going to give me 0. But -2 work too. Okay? You're matching up the variable by multiplication so that when you add them, one of them gives you 0. So what do I times this by so that it equals -6? So -6 and 6 canceled out. Okay? Alright, and then again, what do I do with this 45? Put it into this equation here to solve for my y. So we'll do that. 45 plus 3y equals 54. Subtract 45. 3y equals 9. Y is equal to 3. Solution, write it as coordinates always. Write it as coordinates always. 45 and 3. And then you check your answer after.
This section was just elimination when I was doing.
This was elimination again. Okay, I got one more to show you. I want to show you when there's one that isn't. Okay, here's a doozy. All right, here's where it gets a little bit more complicated. Questions about this guy? Same stuff, right? From here down, it's the same substitution. Okay, so here is, right there, equation A is okay. So, first things first. First things first. You want to match up the x's with the x's and the y's with the y's when you stack them. So let's do that first. Okay? So I'm going to go A is written the way I like it. 3x plus 2y equals 2.
Should you ever change them to y equals
Okay? B now. What do I have to do to get the x, the y, and the number? Add 5y. Very good. So I've got 4x here plus 5y is equal to 12. All right. I'm going to take some magic now to figure this out. Take some magic to figure this out. Now remember, I need, okay, just a sec. We'll go to you in a second. What do I need to do? I need to get one of the variables to have a coefficient so that when it lines up with the variable below it, they're going to cancel and give me 0. That means I need a 5 with a negative 5. I need a 7 with a negative 7. I need a 10 with a negative 10. Some way, somehow. And the only way I can do that is by multiplying both the equations by a number or one of the equations by a number to make that happen. Jake?
You can take like 5y and 2y and you can multiply them by each other.
Okay, so, but okay, you're on the right track, Jake. That's right. So, let's put it this way though. What would you multiply A by, Jake?
By negative 5.
Okay, you say negative 5. So Jake's seeing this already. He says negative 5. So he's trying to set it up for himself to make it easier. So let's multiply this all by negative 5. What does that give me? Minus 15x, right? Minus 10y equals minus 10. Agree?
Yeah.
Okay, so far?
Yeah.
I'm on the same page as him. I like what he's doing here. Just wait, Sammy. Wait. Before you ask your questions, because he's going to make it make sense right now. Jake, what are you going to multiply b by?
Positive 2. 'Cause you got a
Positive 2.
and a negative.
Because you want to keep one of them positive and one of them negative. So let's multiply the bottom one by 2. 8x plus 10y equals 24. 8x plus 10y equals 24. So he decided, his wisdom, that he's going to multiply a by negative 5 and b by 2. And has he been able to match this up so that when I add these two equations together, I'm going to lose one of the variables? Did he do that?
Yes.
I sure hope so. Minus 15x and 8x make? Minus 7x. Minus 10y, add 10y is? 0. There you go, Jake. Negative 10 plus 24 is? 14. What does x equal? Negative 2. Negative 2.
I don't know.
That's cool.
It's neat, isn't it? Right? So, you came up with it by thinking in your mind. You told me, if I multiply 5 by 2 and 2 by 5, I'm going to end up with 10s. What else could I have done there?
3 and 4.
3 and 4. multiply this by -3 and this by 4, or, you know, vice versa in terms of the negative sign, right? Multiply this whole thing by 3 and this whole by 4, and it would have got me the same thing. Let's look. Let's make sure. A, let's multiply that guy by -4. What do I get? -12x. Subtract 8y equals negative what? 8. Okay, great. And b, multiply b by 3.
12,
12x,
15.
15y,
Mhm.
36. Good work. Good work. -12x and 12x is? -8y and 15y is? 7y. 36 subtract 8 is? 28. What does y equal? 4. Hey, look at that.
We did a
I
thing.
got my x and my y without doing that whole other thing where I substituted in.
Yeah.
So if I really like this method, I really like that method, that's all I had to do. Do it twice. Do it once so you get rid of the y's, do it once so you get rid of the x's, and you get your solution. Your whole solution, without substituting at all. Okay? Alright, your question answered? Should we try one more? Let's pick one. I'm gonna pick one that's gonna be unfriendly for substitution and unfriendly for elimination. And we're gonna do both. Okay, we're gonna do both so that we know how. Alright? And actually I shouldn't even say that. I'm not gonna do that. I like to. Because I can. Because one of them is always gonna have a preferred method. One of them, when you write it out, you're always going to have a preferred method. Because if you have a variable of 1 on one of the variables, or a coefficient of 1 on one of the variables, substitution is quick. Bang, bang, you're done.
Both solutions will work for all of them.
All of them, all the time. Okay? So what am I doing? Why am I doing this? What are those coordinates at the very end? Yes! They're the intersection points. What did you do all last unit? Graphed them and found out where they intersected. You're doing the same thing here. You're just not using graphs anymore.
Yeah.
You're using intersections. Alright? You're using substitution and elimination to find the intersection point. Everybody okay? Alright, so let's find one here. Alright. Okay, let's do substitution first. Let's do substitution first. So what am I looking for right now? Coefficient. That what? That isn't 1, right? Because then it's an easy math thing from there, right? One math step and we're done. Okay? So which one do you want to isolate? X in which one? A or B? X in A? Okay, I'm good with that. So let's do it. A, X is equal to. What's X equal to? A little louder. 3y subtract 4. How did I get that? I added 3y. Well said. Well said. 3y to the other side, right? So now that I have x by itself, what do I do with it? Substitute it into the b equation, right? So let's do that. 4 times. Instead of x, what am I putting? 3y minus 4. Add 2y minus 12 equals 0. Good? Anybody not follow that step?
Nope. Where's that negative? Where's the other one?
Did you answer your question?
Yeah.
Good. Anybody else have a question? Anybody else have a question? Okay, so what's the next step then? Distribute. Okay, let's take distribute the brackets. Does that sound right? Okay, so 12y minus 16 plus 2y minus 12 equals 0. Collect the like terms. 12y and 2y make 14y. Minus 16 and minus 28 make, or sorry, minus 12. Minus 28. And all of that is equal to 0. Okay, so let's isolate. Plus 28. Good. Now what? Y is equal to what? Why did you get that?
28 divided by 14.
Oh, divide both sides by 14. Sorry, eh? Okay. So let's go back up here. What do I do now that I have y? Put it into the equation and find x, right? So let's do x. 3 times 2, subtract 4. X is equal to
6 take away 4. 6 take away 4 equals 2.
good for you. What's my coordinate?
2 and 2.
2 and 2. That's where the two lines intersect. So without graphing those two lines, you just found their intersection point. Okay? Are we okay on the substitution method?
I think so.
Think so?
Yeah, I got it.
All right. Let's use the same question. Let's use the elimination method. Okay? So, A again. Somebody read that equation to me. 3x.
No, x subtract 3y.
Hold on.
Sorry.
Oh, that's right. That's my mess up. Okay, what is it?
X subtract 3y equals -4.
-4. Good. Okay. 4x plus 2y minus 12 equals 0?
Yeah.
Okay, excellent. Okay, so what's the first thing I need to do? Yeah, let's put them in the same form. So my x is over my x's, my y is over my y's.
Negative 12.
Where's the equal sign?
Negative 12 has to be on the other side. Plus 12. Okay, so let's watch this. I am just saving space. Equals 12. Agreed?
Yeah.
So I just had to add 12 to the other side. Everybody's okay?
Yeah.
All right. Okay. What do you want to do?
Oh, you will. How would you get a negative times 4 for the x? Negative 4 for x.
By which equation? It's got to be by the whole equation. So which equation do you want times by -4?
By A.
By A? Do we agree with that?
Yeah.
Times that whole thing by -4?
Yeah.
You sure?
Yes.
Okay. So what do I get? -4x plus 12y
Negative 6. Add 16.
equals add 16. We'll go with positive 16. That works. Okay, so then I have 4x plus 2y equals 12. Draw my line. Add those together. Minus 4x and 4x is? Oh. 0. 12y plus 2y?
14.
16 and 12?
28.
Not 4, Lexi. What does y equal? 2. Just like that. Just like that. Okay. Let's do that method again. We won't put that in to the equation and solve. Let's do that method again. What are we going to multiply by now?
Negative 2.
A, I'm going to multiply by what? What is it? Here's the catch, guys and gals. I'm gonna multiply them both by positives. Both by positives. Because one's already a negative. Right?
Yeah.
So let's multiply them both by, what am I times A by? Liam, what am I multiply A by? 2? Okay. So I got A is 2x minus 6y equals negative 8. You agree with me, Liam? Yeah? Ty, what do we multiply B by? 3. So I get 12x plus 6y equals 36. Or, Ty, do you agree? I didn't make any math mistakes?
So A always has to be on top of the B.
No. No. But A comes before B in the alphabet, so why not? So 2x and 12x make 14x minus 8 add 36.
42.
Sound.
You pick your moments a little bit. Anybody want to go in 28?
You're so confident.
What's x equal?
2.
There you have it. 2 and 2. Are we okay now?
Yeah.
Yeah, we think we can handle this? Okay, so here's how this works for you. You do need to know both methods. You do. In 9-1, you're going to just use the substitution method. In 9-2, you're going to use the elimination method. In 9-3, you're going to use the method you like best. So your problems are going to be a little more difficult, but you're going to use the method you like the most. Fair enough?
Yeah.
Any questions so far today? Any other questions? Okay, so by Monday, we're down to the end of 9-2.
Okay.
Okay? So I'm not here tomorrow. 9-1, 9-2, done for Monday. Got it? Let's, while we're at it, let's make a plan of attack here. 9-3, Monday. Review, Tuesday.
Okay.
Wednesday is the half day. Causes,
Test Thursday.
causes a problem for you because you're losing review days. Right? So here's the thing. You've got, if we test Thursday, that leaves you with Friday and 5 days next week to study for, so 6 days to study for your exam.
Yeah.
I think you don't need to review 8 and 9 because we just did them, right? So that leaves you 1 to 7 to review in 6 days. So if we do 1 a day, and one of those days we do 2, we'll put 2 together. We should be able to be ready for our exam. Does that make sense to everybody?
Yeah.
Okay, so that's what we're looking at. So that's okay. So we will test on this on Thursday next week. All right? We
could-
start reviewing Friday, Unit 1. And I think Unit 1 and Unit 2 are all the measurements, right?
Yeah.
So we're gonna we'll put the first 2 together.
1 to 5 are all like that's
So-
all information.
Okay, thank you.
Yeah.
All right? That's good. And you have, in your book, you have cumulative reviews. So that's what we're gonna do. We'll do those cumulative reviews all the way through the review. All right? Towards the end of that, you'll get a pre-exam, like what we do for pre-test. Same idea. You'll get that towards the middle of the study week. Okay? So,
Did you say that our exam would be like all the pre-tests you gave us? Like
No.
questions? No.
it'll be off your tests.
Oh,
Okay? All your exam questions will come from the same, they all come from the same stuff. It'll look like your tests. Okay? Your exam is Thursday, the 22nd of June. Okay? Any other questions?
yeah.
All right. I didn't give you much time today. You got 20 minutes, 25 minutes today, but you have all day tomorrow to do 9-1 and 9-2. Not till after class.